Here we have a simple example of a welded structure that is, the cross section is T-shaped. We have two welds. We have on both sides of this hat we have a weld that has like an A dimension of 7 millimeters. That beam has been mounted rigidly to a wall, and we are applying 5 kilonewtons of force at the top, at the end here. And the task here is to calculate the shear stress in the weld. And the first things which we do is we bring in here the equation which we are going to use for this task. Well, the tau z is V, which is the shear force, internal shear force, S as a function of Z divided by second moment of inertia in bending multiplied by the B at location Z. Let's draw the free body diagram here. So at the wall here we have F A Y. We also have F A X, and then we also have the bending M A. And in here we have 5 kilonewtons of external force applied to the structure, like so. First step is to do, just like always, is to calculate the equilibrium equations. Like this. Well, we have only one horizontal force, which is the support reaction at left hand side, and that is 0. Then we have FAY minus 5 kilonewtons is 0. And then we would have the moments. We have minus MA minus 300 millimeters multiplied by 5 kilonewtons is 0. Well, from equation 2 we can straight away see that FAY has to be 5 kilonewtons. And then from equation 3 we can solve that MA is minus 1.5 kilonewton meters. In this task, what we're only going to need is the shear force. You should be confident at doing this already. So the shear force in this case, because we only have one external load at the tip of the beam, and then here we have the support reaction at the left hand side, we straight away see that our internal shear force will be in positive direction, and it will be the same value, linear value all the way through positive, and the value will be 5, like that. Simple as that. Okay, what can we do next? Well, now when we have calculated the internal shear force, we can proceed to calculating the second moment of inertia of the profile. So the profile is T-shaped. You should be already confident at calculating this yourselves. So I will just give you the values. When you do the calculation, the Z0, what you would get, you should get 49 millimeters to the location of the neutral axis of the profile. And then also the second moment of inertia, once you calculate that one, you should get 10.8 uh, 10 to power 6 millimeters power to 4. You should be capable of calculating this yourself. So now when we have solved that one, let's draw the cross section here so we understand where the shear will happen in this profile. So we have this hat here. And then we have here this part of the profile. And if we draw here the welds, I'm gonna exaggerate the size a bit. So these are the welds. And since the welds are on both sides like this, the shearing in these welds will happen through here. And this dimension here is now 7 millimeters. A7 means that the A dimension, which is this dimension, is 7 millimeters. So now using the formula for shear stress tau z, we can calculate that tau at this location, which is yes, so at that location the tau z will be the shear force 5 times 10 to power 3 newtons multiplied by the SZ, which is basically the area that is gonna shear off. The shearing area is the area of the hat here, which is 120 millimeters multiplied by 20 millimeters, which is the thickness of that hat, and then multiplied by the distance from the neutral axis of this to the neutral axis of the entire profile. That distance there, and that distance is 39. And now we divide this entire thing with the second moment of inertia, 10.8, 10 to power 6 millimeters power to 4 multiplied by 2 times 7 millimeters. Why 2 times 7 millimeters? The reason is that we have the weld on both sides here. So we have 2 welds, so that in length, total length of the shearing area or shearing line is 14 millimeters, so 2 times 7 millimeters. And when we calculate what this is, we feed these values to our calculator and we will get a value of 3.1 megapascals, like so. So that was a really quick example how we can calculate shearing in this kind of scenario.